Welcome back, dear students. In this lesson, I want to take you through to create an ERC20 token, which is a fungible token written in vanilla or native Solidity for Ethereum or any other EVM blockchains. Then, we'll now take it after we've created. I will try to deploy for you. Then, in subsequent lessons, we can now take and modify it, which will give you more understanding how this native Solidity same fungible token works on Ethereum, and then having that same ERC20 but known as SPL token, fungible token, our program on Solana. So let's take it step by step. Since we are creating for our Solidity Ethereum as a 20 token smart contract, so let's see. I think in the previous lesson I already explained to you that we need a library, so which instead of writing a lot of code ourselves makes it easier, because these ones has lifted a lot of hard work and time for us. That's one. And two, they have been audited, so we can just write our smart contract and there should be bug that we were not even aware of. So when you now have those that have been used by different people but you tested, then you can easily use it with more of rest of mind, that it won't just fall into exploit. So here now we have the Open Zeppelin, and Open Zeppelin has this contract wizard, which you can see we can use it to create our ERC20 token. And here you start getting let me first create this, but you can see what we have been learning, that these are real world projects and you begin to see them in action. So see the constructor, and you can see it right here. Let's have you have this is the token, so maybe we just call this ERC20. You see, so because this is inheriting, is it not conflicting? Because this is inheriting, first is importing this, which is the library I told you about. We'll still check it out. Let's go. You can see it now. So there is, you have your pragma, the imports, which is when you see in native or vanilla Solidity, i.e. this an interface, something interface to ERC20.so, then some other extension and things like that was imported. Then this is the actual contract. ERC20 is context. This thing is imported, so it is, because this, you can remember when I was talking about inheritance. So when you inherit from other contract, I think this is done to make the contract more modular, so that everything doesn't jump in, and then when there's issue, it even creates security issues. So some features are created as a standalone and then added like an add-on, like this metadata and things like that, the context. So then you have your mapping. Remember, key value pair, you have the address mapping to the value. So this will be like address and token. So you can check balances, and as well you can see the private is there. That means this will not be accessible outside this particular smart contract. Then you have this as well, private allowance. You can see this now, this unsigned integer 256, and it's private for total supply to hold. I've explained to you, because the architecture of Ethereum is different from Solana, so everything you need to build it out in a single smart contract. How it will handle storage, account, everything must be tracked, and everything in terms of fungible token, the ERC20 token, is handled by that smart contract. You understand? Unlike Solana, that you already have a specific SPL program deployed that undo all those things. So all you need in your own smart contract or program is your ability to mint, ability if you want to mint new one. Are you having total amount supply, which account you have the authority that can mint more later or something like that. You understand? So now you have this as well, name, and you see these are private because after all, you don't need to be allowing people to just come and change the name or this. Even you shouldn't interact with the smart contract to change the name later on for a token. So if you are changing name for whatever reason, it's better to deploy another smart contract. So you can see it. Then here you have the constructor. All these, remember, are like your state variable and contract storage. So then you can have your function, which has the decimal. Then your arguments can be a, like total supply. You say public view, which with the public, this means this will be accessible. Then within, outside, view tells us that this doesn't change anything. The smart contract is us. The virtual is part of what is added, and then when you are writing library and all those things majorly, then remember this override keyword I also talked about in previous lesson. Because this is a library, I may decide to want to create a total supply on my own and specify additional code apart from this. So this makes it easier for me to override it when I inherit this function. So it doesn't force to what is there that I'm not tied or limited to it. And see, most of the function have the override keyword. Then the return is, if you want to return a value, you are expected to have this. Then what data type are you returning? You remember for Solang, this will be U864. So that's just the basic breakdown. You want to check the balance of this is the transfer. You will send in address, then the argument to which address are you sending it to. The data type is address, then the amount you are sending, which is uint. And remember I said uint only take positive number. Int, that's integer, unsigned integer. Uint takes positive. Int takes both positive and negative. So you don't want to do that. Somebody means with negative account balance, token balance, can then transfer. that would be a great exploit. So that's why you see most of these reward or smart contract like this that we're checking usually have the uint, not int. So this is it now. You see it's like the same thing. Then transfer owner to an amount. Then you can see this message sender. So this call on message sender, I think this was inherited. So the message sender, I've told you, represents the address that is interacting with that contract. So in this case now, it's like address equal to owner, transfer. So it has to be assign it as the owner. Then you have allowance, giving other people a particular amount to be spent. Then approver, you can approve it. Then transfer from, increase, and things like that. So you see all this code has been written for us that we don't need to write again. That's the advantage of library. You can take time to study it. Then that's what was important. You can imagine that. So that's why you can see that this contract, our main contract, becomes so small because we have imported and a lot of things we can make use of. The transfer, the everything. We only need to rewrite some of these things here, like all this transfer and things like that, if we want to make some custom features, introduce custom features that are not here. If not, it just gets imported and then make use of it. So we can change it. So to make it a bit different, let's say maybe SPL ERC20. ERC20 SP also. So we can see this inherited this particular contract, which is ERC20.so. That's why it's referring to it in here as ERC. Yeah. So then we have the constructor. You can see which this constructor demand that you pass in name. And you can see this memory that I was talking about when we talk about contract storage, that I said we also have things like RAM. So when you are dealing with like string in Solidity, you are usually need to state it in memory. So it doesn't go into storage because you are only passing this temporarily. You just want to pass it, then make use of it and discard it. What you've passed in, and then go and make any changes you want to do. So you can save it temporarily in the memory. Then you have this, the name, which is a string, then the string for symbol as well. So you need to pass in this constructor values. That's why you can see that we are passing through it here. You see it, ERC, and string, string will always be in a quote. So then this is the value. We can change it here. So what should we do? Make this ERC20, sorry, ERC SPL. Yeah, let's make it that. So you can see it now, ERC SPL. So that would be the name, that would be like the ticker. Then pre-mint, that's the amount we want to pre-mint. So if we want to pre-mint at the point, then we may need to put it here. You see that immediately I put it, this appear, let's say 1000. Then you can see it mint. It's calling this function that helps us to mint, F3 mint. You see it, this is the function here. Let me clear the search. You see it, so it calls this function, which actually need you to pass in account amount. They require account, not address. They're sending it address 0, so you don't meet to, your token will just be burnt and not, you don't have access to it again. So before token transfer, so all these functions will be called, and usually the common practice when you see functions like this, it is like maybe internal or something. It used to have underscore like that, but not compulsory, just to differentiate between them. So that's why you see it was called. Then what it needs, the address of the sender, then the decimal, the number you want to meet, which usually is 18 decimal and things like that in Ethereum. So it's doing the conversion for us here to ensure we have the accurate something. So this advantage of all we have gotten right from the library, and from there we can have burnable, mintable, a lot. You see mintable, you see it, it's import owner, so that if we want to mint, for example, you don't want just anybody to be able to mint your token. Oh yes, you understand? So with that, there had to be, let's see, yeah, there had to be owner, only owner. So when you go to this, you see where it has, been limited to just the owner, say check owner and things like that. So must be equivalent to message sender caller is not owner, so that whoever is the owner would have been assigned with this constructor. You see, would have been assigned with the constructor and things like that. So the wallet that deploy this contract becomes the automatic owner. So if somebody else goes in, even if it's the same person, but now log in or get into their wallet with another wallet, Ethereum wallet entirely, if they try to mint, it will deny. So they have to always come in through that particular message the sender that have been saved in the contract storage. You remember inside Solang, yeah. So a immutable one. So that's it that you have here. Then I'm not doing all those now, anyways. So what I'm just showing you as more features. You deal with different libraries and more. All these are for upgrade. But thanks to Solana, the way it has been splitted, the code, executing code is different from the one that is actually handling the data. So it makes it super much easier to upgrade a contract on Solana by default than Ethereum that you need to do a lot of ups and downs here. So I just give you a basic explanation to have idea. Then you have security contract. If you want, in case any security auditor company spots security flaw in your contract, they may mail you through that email. So that's it. Then the license, MIT license most usually, because like open source. So here now, all we just need to do is to come over here. We have it already, and then get it deployed. So we have already talked about this. You know the pragma, what it is about. And then once you have this now, we can copy it and go to our remix. Then remember, inside contracts, you can create as many contracts here. So similar to this Solidity, you can create as many contracts here. So let's create new file. And what's the name of that token? We call it ERC20 SPL.so. So you can see it now. Did you notice immediately I copy a lot of things was imported? You see all these contract tokens, you see ERC20.so that we imported here. ERC20.so that we imported here. So you can see it much better. Yeah, the ERC20 token that we imported here. Nope. I don't want it to. Okay, yeah. This one is for the initial minting. So mintable, no. So initial minting, I want to mint 1000. So here we have it now. You see a lot has been imported. If you click on here, you see it, that same library I went you through on the GitHub, on their GitHub here. So we have imported it just using that import. You see it. So then these are for the interface and a lot of things that have been imported. So all this has been done. All these are what makes it easier for you to now, have this kind of a small code and then be able to deploy. But it's not that this code is as simple as it looks in the surface. Like I told you, it's like a macro in Rust where you just write a simple line of code, but that could eventually help you run about 20, 30, 50 lines behind the scene. So because it's like a built-in something. So that's it here now. You can see it mint. And our contract is ready. You can mint your token. You can edit it anywhere you want it as well. The name, here, you understand, and we have it to compile. Once it's marked, if there's error, for example, let me add one, you see that's not compiling, it's in red, so make sure it's in green. So then you have this on auto compile, then you come here to deploy and run. Let's clear all this so we don't have anyone here. Then we always have free account you can use to test here. Let's deploy. Cool. So our token has been deployed. You can see it. Let's see. You can see it, approve, decrease. You remember all these assessor ones that come in. I think those ones are the ones that always come in this like orange color when you are dealing with remix, because it's not that they actually have a function there. The functions are actually like all this blue, but the assessor, they are, the moment they are declared with public keyword in it, then they have this assessor, so you can see it. You can know which decimal is this. Is only on 18. The name of the token, you see it. ERC20 SPL. The symbol is ERC SPL. The total supply. See, the total supply here is what? Ethereum uses 18. So you count 18. We did 1,000. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And what is left? 1,000. So for you to have more clarity, let's bring it there. Let me make it comment so it doesn't affect what we have. So you have it here. Just count from the back here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then you have this. So you see it now. So this like 1,000. Yeah. So that's what we minted. So don't be confused by this each number. So that's how Ethereum is. I think Solana is more of like 9 decimal. Yeah. So by default, Solana is 9 decimal compared to default on Ethereum, which is 18. So all this you keep in mind when we are modifying this smart contract later on. So I think I've been able to put you through, and by being able to deploy this, now we can even, should we try to decimal transfer, increase, approve. So you can transfer, for example, the symbol, the balance of this address. Let's see. You see, this is the balance of this particular address. So we didn't say it should be mintable, so you can't mint anymore, but you can transfer. So let's say we want to transfer to this second wallet. Let's copy that and go back. Then let's do a transfer. Amount. So it depends on this, let's say 500, but we might need to also include the 18 numbers, you understand? So, but let's see, transact. So you see, this was successful, and I wanted to show you something here. You can see that as we are doing this, you have a lot of things going on, like this log, which is an event from this wallet. The topic indexed event is what? Transfer. Then the argument, you have the wallet maybe that was sent to, and the wallet that sent it. You understand? So from this wallet, then to this wallet. Well, then what's the value? 500. Do you understand? So with this now, you can hook up your front end through things IDL on like Solang, Solidity, or other ones like Web3.js, Ether.js straight on EVM. So you can now take this and show them, okay, at this time you've transferred this, at that time you've transferred this. So this event log in action. If you go to this ERC20, let's see it here. Yeah. Let me bring this down. Can I search? Okay, let's see. You can see events. You can see this is being emitted. Emit transfer. You can see it now. So if we look for events, coming, I can look for events. No. I think this might be coming from some of this inherited one. So that's why we didn't see it directly being declared, but at least we can see it being emitted. So you can see it being emitted here. You see it emit transfer, the address, then the account, then the amount. You understand? So this, so that when somebody mints, you can know when somebody transfer, like now, emit transfer, the account, the address, the amount. So all this help you to track. That's why this was able to generate this. You see event, the transfer. So that's the transfer event. So those are the basic things I think you need to know when you want to deploy smart contracts with vanilla Solidity for EVM. And having this kind of knowledge will now help us as we now create, using also Solidity, but Solang Solidity, to create similar ERC20 but SPL token on Solana. So that's what we'll be doing in the next lesson. So if you get stuck, if you need help, try all these things yourself as well to learn more. Try to deploy and, do the exercises and things like that. So, and we'll be able to say, so in the next one, we will now try to modify this. So is it always there to support in the community. I remain Solomon Foske. Keep the programming spirit alive. Your only assurance to succeed in the long term as a developer. Thank you. See you in the next lesson. Peace and bye.